speak English. Unfortunately, I don't speak Slovak as good as Boris, but nice to come here. So I'm Massimo Polo. I'm general manager of Wisycom. I'm here because they invite me to talk about frequency. So I'm gonna talk mostly about frequency situations. So then there's also some Wisycom products. Wisycom, I don't know if you know the company. We are working and making wireless systems, and we are basically running most of the biggest events. Well, let's see if I can show you. Okay. No, it's not. Yeah, it's the beginning. Can you do it? Sorry. Okay. Now quickly, I just want to know what we do and what we are. So basically we are... Okay. No, I like this, it's fine. So, I have three presentations now, because they want me to talk about frequencies, that's about digital technology, analog, whatever. There's too much to talk, and I think it's useless in such a short time, but it would be nice to tell you what is basically the feedback we got from main organization worldwide. We're running show in all the worlds. Basically, we, as a company, we make, we're an Italian company, but we're making systems for many fields, like studios, ENG, big shows, reportage, and intercom. And we're running most of the biggest shows in the world. We're running Formula 1, we do Tour de France, we do a lot of things, both with wireless products and also with fiber optics products. So basically, I have to work with people, many organizations. For instance, we're starting next March the new championship Formula 1, and every 2 weeks we need to play with frequency. We work with MotoGP also. So we work on making all the biggest show, and so then we need to talk with all these organizations. I don't know the background of you guys, but I think most of you that work in the broadcasting and the audio and live business. And as you know, most of you that used to work with cables, of course, audio. I mean that's XLR cable, and it's kind of common. We are working in the frequency domain. So basically, the cable are the frequencies, and what is happening worldwide, and not only Europe, but as you mentioned, I didn't understand the Slovak, but I was looking to frequency, anyway, what you were telling, is that the frequency is changing mainly because of many situations, the digital television, and also the 4G. So you were talking about that, but just
4G and 5G.
Yeah.
Tomuto asi rozumeli ste, hej,
well, 5G...
Keď ne, tak dvihnite ruku, ja veľmi rád preložím, ale v podstate taký úvod, že čo firma Wisycom robí.
Okay, we skip this. Okay, it's just okay. For Wisycom, we did big events anyway, but this is not the topic. So he was talking about that, but basically, the main difference for the past is that in the past, okay, let's skip this. In the past, you can work on top of analog, because even if channel was busy, you can work on top. Now with digital, you can work on top of it. You can work only on the intergap. So it means that the digital system will occupy all the spectrum. And of course, there's also another problem. The 4G, let me see that. What's the point of this one?
Yeah.
So the 4G is becoming bigger and bigger. You mentioned that now it's basically there is the first 4G between 800 and 840, so basically lose like 60 megahertz. There will be actually in 4 years. It depends country by country. They will lose another 100 megahertz, and the television will further shrink down. So basically, there will be less less empty spot to work. That is a big problem for us because we, as the time being, I mean, I was talking with some of you. I mean, that's, you know, that there are coming out system with 2.4 gigahertz, system with other frequencies, but unfortunately, those frequencies are not so good for professional business. I mean, if you're running a couple of frequencies in an installation, like in this room, working 2.4 gigahertz is pretty fine. It's cheaper, it's working fine, no problem. You don't need to plan frequency, that's fine. But if you're making a big shows with wireless camera, LED walls, and there's no way to make it work. So it means that we cannot use those frequencies, and the frequency we are using now, they're going away. And working on top of terrestrial television, it may be an option in the future. It may be something we want to do. So basically, there's a lot of things that a lot of new products coming out that helps solving this situation. But the message is that the frequency is going to change. Definitely, if I have to buy a system now, in Europe, I wouldn't buy the bandwidth 700, 800, so this is a general consideration. I mean, of course, you want to buy a system and keep it for at least 3-4 years. Yeah, I think the changeover here probably will be becoming effective like in 5 years, 4 or 5 years.
2020, I think.
Well, they say in countries like 2019, but it depends. I remember when they first make this changeover here, I was like 2008, and we were selling a very big theater in, was Gothenburg, in December. And 1st January, the Sweden government say, you cannot use that frequency anymore. so that was because Sweden is, as Ericsson, which is a very big company working in telecommunications. So they wanted to be the first to use the 4G to sell to all of Europe. So basically, Sweden, I think, was one of the first. I think the switch over of this in Sweden was like 2010.
Áno, v podstate o histórii hovorí, to ste asi dúfam, že rozumeli, že v podstate stále sa bavíme o tom, že 4G štartuje 2010, u nás to bolo neskorej a tie ďalšie frekvencie, o ktorých som hovoril, sú v podstate už na spadnutie, to už je v podstate istota, ten rok 2015 v novembri, s tým, že to prechodné obdobie u nás bude trošku dlhšie, ako vidíme aj ten nástup. Nie je to až taká tragédia, ale radšej vás budeme strašiť teraz, ako potom bude neskoro, ale je dobré o tom vedieť.
So generally, so this is the situation, and we, as a company, we try to, of course, run all the technology that allow us to increase the efficiency of the systems. The future, this is the future for Europe. So basically, will be another 4G services squeezing down. In some countries, well, this is not very well defined. So there's two things you have to consider. Telephony is very powerful. Means that the telephony make this change very quickly because they have a lot of money. But also there are a lot of television interests regarding the 4K. For instance, in France, Samsung and Sagem, they want to sell the 4K television, so they need 4K services. So it means that when you start having a 4K television, then you need a lot of bandwidth. So probably you will occupy more channel than now. There's also another problem that we will have in the future. We may go with the DVB-T2. Is that now you have a situation of this frequency that you see it's like a comb. There are some frequencies are occupied, some frequencies are not. That because the television channels is a, so to speak, is a network, so to speak, called a multiplex network. So I don't know the city in Slovak, but this is Bratislav, right?
Yeah.
So basically this is Bratislav. And your main television, what's the main television here? Public television?
Slovak television.
There's an acronym for that? Like
STV.
Channel what? I mean,
two more channels. Here in Bratislava?
One channel, just to make an example. You know what's the television?
To je 40. Kanzik.
Okay, it's Slovak 1.
Yeah, give Slovak 1.
Okay,
it's 750
no, okay, the main issue is that, for instance, in Bratislava, Slovak 1 is in the frequency, like a center like 500 megahertz.
Yeah.
And another city close to Bratislava?
Where is Trnava maybe? Or Vienna, maybe Vienna.
Okay, it's not as low, but anyway, let's say Vienna. Yeah. The same channel here, the Slovak one, cannot be in this frequency. They put in another frequency level, 550. Because, so technically we say that this is, because they don't want the two frequencies to interfere together. They call that a multiplex network. So in the future, DVB2 will allow to have single frequency network. So this frequency will be the same as this. As an effect, you will not have a situation like this. This is like a comb. You have this is the channel in Bratislava, for instance. Yeah. And in Vienna, of course, those channels are not used because otherwise they will have interference in the middle. So this is not used. They're using the other channel in Vienna. So this is Bratislava and this is Vienna. So it means there's a situation where a channel is occupied in Vienna and is not occupied in Bratislava. What is received for instance, Bratislava is basically a small channel because this channel is far away. Normally, DTV, terrestrial television, is perceived as a noise. It's like having the noise floor going up. As a fact, you can go as far as before. In the future, if they don't have this, if they have the same frequencies, you have a situation where they put all the channels together. Without any...
You mean that starting DVB-T2?
Yeah, that would be more time, but that will happen. And of course, you will have less spots. It is kind of strange. I'm Italian and...
Toto rozumiete, hej? Nemusíme to aj... Viete asi čo...
Vieš čo, zhrň to, hej?
Čo bude? Zhrnem to? No, nesmíš, Igonku. Zhrnutie je také, že DVB-T v podstate vysiela teraz tak, že máte multiplexy, to znamená, že mesto od mesta nesmie v podstate vysielať na tej istej frekvencii, pretože sa navzájom rušia. Hej? To znamená, že v Bratislave je 44. kanál, tým pádom v okolí Viedeň alebo Komárno, alebo kde by ste mali s podobným výkonom 50 kW celá výmena, nesmie byť na tom istom kanále, musí byť o kanál dole, alebo väčšinou sa to dáva viac kanálov. Ono je to potom, budete to vidieť na tých skenoch, ktoré mám vlastne celofrekvenčné, že sú tam aj teraz je v podstate relatívne ešte kľúč, že aj v Bratislave, keď Kamzik vysiela, tak sú tam relatívne veľké diery s tým, že za určitých okolností Viedeň alebo tie ostatné vysielače sem nedopále. Budete vidieť potom, že v podstate za určitých okolností, keď ste vo vyšších budovách nad Dunajom alebo kde to v podstate sem prenikne, tým pádom porty tam môžete dať, ale riskujete s tým, že budete mať dosť veľké výpadky, pretože ten digitál vysiela v podstate v tom 8 MHz pásme, ide plný kotol. Tam to není jak v tom analogu, že ukazoval, že ste mali spektrálne diery, kde ste sa s portami pichli barzde, potom v podstate nie. Tým a potom vlastne to pokračuje tým, že DVB-T2 bude používať single frequency network, to znamená jednotú frekvenciu, tým pádom Bratislava, Viedeň, Komárno bude môcť vysielať bez tých nutných dier, že budú vysielať na rovnakom, tým pádom tam nedáme už nič. Ale to je budúcnosť, ktorá u nás na Slovensku ešte chvíľu potrvá, ale ako sme sa bavili s Massimom, zase je to len o tých peniazoch, že v podstate tí telekomunikační operátori majú kopec prachov, takže je to len o tom, že kedy to naštartujú a zahltia nás v podstate LTčkami, 4Gčkami a 6Gčkami a 8Gčkami, takže potom to bude vyzerať tak, že v podstate budete mať len štrúdlu a možno niekde naozaj v tom Národnom divadle slovenskom alebo niekde v tom Carltone, že tam sa bude dať potom fungovať. Ale to je také asi zhrnutie, že v podstate to je rozdiel medzi multiplexom a tým vlastne, že DVB-T2 bude mať SFN-ko, ale to T2 u nás ešte nejde ani testovacia prevádzka v Prahe, myslím, že jeden vysielač, ale tento rok by mala byť testovačka aj tu T2. Ale ako hovoril, záleží to o tom, že vo Francúzsku predali veľa 4K-čkových televízorov, tak tým pádom vysielatelia chcú tlačiť 4K. Jediná možnosť ako 4K je v podstate tá DVB-T2, ako aj slovenská televízia. Myslím, že testujú v Prahe ten prvý stream.
Okay. No, actually, that's kind of funny because in Italy we're having the digital dividends, but in Italy without dividend. I mean, dividend is that if you have a TV channel with analog, they give you a frequency and a multiplex. So they basically, since a multiplex can have like 5 to 6 frequency, you're really freezing, freeing room, so we will have more space. Because in Italy we had for like 10 years like a situation, political situation where the Prime Minister was actually owning most of the television. They didn't do the dividends. So in Italy, if you go to Italy, all these channels are occupied. Really, it's a kind of bad. When some people is going to Rome like to make interview to the Pope or whatever, it's a very bad situation. So basically in Italy, the only place we work, maybe, is here, the Internet. So it's a good place to test those systems. In the future, this situation will not be as bad as in Italy, but will be close. So that is why, as a company, we really develop all the technologies in order to squeeze bandwidth. So our main technology that we try to develop is to increase the bandwidth efficiency. So normally, this is a situation in Europe. In America, what is happening is basically starting next year, they'll be running an auction last year for another 100 megahertz. So basically, starting 2016 in the States, they will only have like 100 megahertz left. So that will be actually pretty bad. And we are thinking now actually in the States, but actually there are already some products. For instance, we have friends that are making intercom in the States. They're going back to VHF. So there's no other solution. So basically, the situation is moving a lot. For the next 4 years, probably that will be the situation. That will be probably 2019, 2020. Yeah. And this is more or less the situation. But because of changes of this frequency, it will be more difficult to work. Okay. So generally, fortunately, the technology of wireless microphone, generally technology electronic is getting much better. And there is many things now we can do that we cannot do in the past. And just to summarize here what we think is basically the requirements of, how to say, next generation systems. Of course, we are forced to do it now because we are running big shows worldwide, and so we need to do it. I mean, but that will apply also to you in the future. So definitely, having a good band agility will help you to find the best parts. I don't know how much time we have here. For now? Because they're talking about interference. It would be nice to have a general understanding. I mean, interference of a television is not the only interference you have. I mean, they're talking with some people. If you're running a big shows now with big LEDs, then you'll be experienced problem with LEDs. Probably we'll be talking about that later. I mean, agility is a good idea, a possibility, of course, to look for the spectrum, but of course, then to work within the spectrum you want to work efficiently. I mean, if you see what the last 10 years they do, they started using more services. On this bandwidth, there are also intercom, there are wireless camera feedback. There's a lot of services running this, and in many cases, you cannot control all of this. Especially LED walls creates a lot of noise that must be managed some way. And of course, we try to work in technology that will use less bandwidth. And for two reasons. They are more selective, and because of their narrow bands, there's less noise entering into the system. So a system which is narrow bands is the same power is more selective because less noise will enter the system. So basically, just to make an example, if you have a narrowband system with like 50 kilohertz and the system 200 kilohertz, like a normal hybrid system, the system with 1/4 the bandwidth will have 1/4 of the noise, because basically this is the bandwidth is working. It's like having 4 times the power. So it will be more efficient, you can put more system. The problem with doing this technology is basically you need to have a system much quieter. So it's making this narrowband system with the same quality of existing systems means having a system which is like 1/4 of the noise. There is an idea about So many systems are working in the frequency domain. So basically a frequency is like a cable. When you work in a studio, you can work at the line level, you can work at the mic level. Normally, if you have like 10 meters cable, it's not a good idea to work at the mic level because you have some noise floor, and which is basically depends how much cable you're running. And then of course, if your signal goes down, your noise is the same, then the quality you get at the end is not so good. The same with the frequency. Working narrowband means that having a low level of signal. So in the frequency domain, the level is the bandwidth. So working with 1/4 the bandwidth is like working with a cable at the mic level. So the difficulty is to do it maintaining the same quality. Again, the technology is getting much better now, so we can make systems that much lower noise, so that is possible. That's basically what we are going to develop in the future. Probably not NAB, IBC will be developing systems which are working narrowband, and probably receivers that are going to work both VHF and UHF.
Massimo Polo. V krátkosti, v podstate, len takto zhrnem, že Wisycom sa zaoberá otázkou. Štandardné teraz systémy v podstate fungujú v klasickej FM modulácii, kde sme na šírke 0,05 MHz a oni vlastne sa snažia pretlačiť sa po 250 kHz s tým, aby ste v tom multiplexe digitálnom vedeli vlastne vysielať mikrofóny v tých medzerách medzi dvoma multiplexami, čo je v podstate ten DTB intergap, kdežto dnešné systémy tam v podstate nenervete, pretože tá medzera medzi tým DVB-tečkom není to štvorec, aj uvidíte v podstate v tých skenoch mojich, bude to vidieť, že ono je to taký lichobežník, takže v podstate budúcnosť zatiaľ u nás, ako aj Massimo hovoril, do tých 2019-2020 zatiaľ relatívne máme čas aj v podstate v tých 700 MHz, aj v tých 800, ale dokedy, či sa to nezblázne potom, že keď sa to spustí, tak ako v tých Čechách alebo v okolitých, že budú peniaze, tak v podstate od tých 690 pôjdeme dole, alebo tá Amerika v podstate ide od tých 600 MHz. A bolo tam spomenuté, že vlastne tá narrowband modulácia potrebuje 1/4, myslím, že zo šumu, tým pádom kvalita ide hore, ale tým pádom, že aj súčiastky sa zlepšujú, tak viem, že už testujú a iní, ktorí majú, už pracuje v tomto narrowband modulácii. To je asi tak v krátkosti, môžeme potom cez prestávku viacej o tom ešte podebatovať.
Okay, then of course, there is a lot of other technology that can help you to have a better coverage of the system. Another thing which is very important, which is coming now, is that if you have a problem with signal, a good idea would be to put more than one antennas. So in very big studios, it's normal to put more than one antennas. The main problem doing this is that when you put antenna together, then let's make an example here. When you put antenna together, I think it's here. So we skip this. So basically, skip this quickly. Okay, when you put antenna together, it's a good idea. But the problem is that all the noise will enter your system. So there are now possibility of, it's a cost-effective way to route RF. Meaning that you can create a situation with this, with a lot of antennas, and then activate the antenna that you need, or the group of the antenna that you need. We've been running this since many years. This is very important because you understand that when you have a lot of noise, like in the situation of terrestrial television, what is reduced is the coverage. If you have noise, basically when the signal drop down the noise, you cannot work anymore. Instead of having 100 meter coverage, you have 50 meters. It means that you need to put an antenna with 50 meters. But making an array of antennas and combining as it is, it creates a lot of problems. First is the noise, because all the antenna will put the noise on the system, at least the noise floor of the amplifier. But also that creates a very big danger system that can receive also LED noise or other system noise. So it's making a system like this, it's a good idea, but you need to have the possibility of changing if something happens. So that's why we develop for big shows, but normally there's something very, very nice system that can basically, an example, can use it to route all the RF. we've been doing this for big studios. For instance, this is an example of an installation in France. This is basically an installation we done this picture in Canal Plus in France, which is one of the biggest television. And their problem was basically to be able to work, to centralize all the RF, all the control room, and all the studios within RF matrix. So every control room can work with every studios, but it can basically enable the RF on this side whenever they want. So basically they are able to create the system as a very big antennas. And of course, if there is some noise, I mean, those antennas are not enough, they can enable other antennas. But they can also, in this case, cover different area, of course. We started this as basically to solve a problem of big studios, because basically managing big studios like this is complicated, and they like the fact that they can work with every control room, with every studios. But then we, because of this problem of terrestrial television frequency and also LEDs, we start using it effectively in live, in events. For instance, I have to skip it here, but let's see if I can see it quickly. We'll be running, for instance, a show.
O multianténach potom vám ešte poviem neskôr, toto bola v podstate ukážka, ako sa to bude dať potom v podstate do budúcnosti, že budete mať viacej antén s nižším ziskom, ale to budeme potom rozoberať ešte s pánom Zeleňákom, čo sa týka antén, že čo sa s tým má, ako sa s tým dá ešte spraviť.
That's an example. This is one of the biggest shows that they run in Denmark. Of course, I take it because of DPA. So yeah. No, I'm kidding. DPA is a Danish company. Anyway, this in Denmark, this factory is very famous, and they do the final in a big stadium with a lot of people. And again, you know, I don't know if they do X Factor here.
Yeah.
You know, the feature of this show is that all of that, they have big LEDs. So that creates a lot of problems. We can show the problems. So.
A skeny potvrdzujú, aj vám ukážem, že v podstate to isté aj tu, že ledky vlastne vyrábajú pravidelný šum, ktorý zatiaľ, keďže máme to pásmo, že sa vieme pichnúť aj hore na 700 alebo dole, dá sa s tým robiť, ale tá budúcnosť tým pádom, že ledky, všetko tak, to je...
In this case, you don't see the television because the stadium was very well shielded, so you don't see any TV channel, you just see LED noise. So in this case, we're using the wideband of the receiver to find the best spot to work on it, but since we were running, so basically we are able to calculate interpolation plan on the minimum, because normally this kind of noise of LED is kind of regular, so basically we can work on top of it, but again you need the wideband. So in this case it's an example where television is not the only problem you have. You don't even see television channel here, it's all under the noise of LED. So basically, but in this case, the problem is that this was a big show, it was a live show, and you know, everything can happen in a live show. Many services can go on. There's not only wireless camera, there's not only wireless microphone, there's wireless camera, a lot of services running on the UHF. So they want to be sure that everything is working fine. So basically, what we do in this case, we put more antenna than needed. We could run the show only with these two antennas. But we connect all these antennas with the RF matrix. In this case, we run the show with these two antennas for the stage, and whatever they have a problem, for instance, they can turn on the antenna where the action, I mean the live events, is going on. So basically we can make a live intervention if something goes wrong. So this is an example where RF matrix or RF routing with more antenna can be useful in live events, not only for big studios. Example of this is, for instance, like I will show you later, but that would be nice maybe to show some example. This was the Formula 1 last year. Skip it. So this is basically another big problem. In this case, the problem is not the frequency. They do have frequency problem. Formula 1, I mean, if you make a spectrum during a show, they probably got 1,000 carrier going on. So it's a kind of nightmare because there's not only a carrier of all the television, but every car, they have communication, so it's kind of nightmare. But the problem is basically the area you have to cover is a couple of kilometers. So in this case, we do have the problem of covering 3 areas. This is basically the pit lane, the garage, and the paddock. So different area where they need to make basically interview with the journalists. And of course, we can use RF matrix to many antennas to cover all this area. But in this case, we have an additional problem. Those areas are not easily connected. Normally, we can connect area within like 100, 200 meters with coaxial cables. In this case, we're talking about 1-2 kilometers. So that's why, in this case, basically we are using like a man as a repeater, and we're using basically an RF over fiber system. So we basically starting a couple of years ago, investing heavily in RF over fiber systems. That's also because there is a lot of new technology coming on the laser that becoming this very, very, I would say, approachable from the economic point of view. But in this case, for instance, the reception of the journalists will be this man, which is working like a freelance location. Some people just bridging the RF of this repeater or of a cable, and this is going on the paddock, which can be like 1-2 kilometers far away. So if you see the picture, so this man basically is having receivers and 2 antennas. It's like, you know, as freelance engineering for location sounds, but without mixer. And this is basically the pedal side. So I mean, there's many technology that can be used. I mean, this fiber technology was used like 2-3 years ago, and was kind of advanced. Now, I mean, these products are coming kind of common. I mean, that's, we are shooting, for instance, a movie in San Francisco, kind of famous movie, and in this case, they want to shoot the scene without stopping the camera. So the player will go on for like 5 minutes, so they cover the big areas. So they're using the fiber, that box, to cover all of that. So with this technology, were developed for specific needs. And again, the terrestrial television and the 4G force many manufacturers, I'm talking about Wisycom, but there's many manufacturers working on this field, to develop systems, especially for big events. We all started with big events where it's more difficult to work. Formula 1 is an example, but for instance, it was last year I was involved, so to speak, into the frequency, into the IM system for the Olympics, and that was a big problem also. I mean, all these big events put to us the attention to how to solve it, but then all these products come to normal broadcast or normal location sound situation. I mean, this system was equipped by a normal card for freelance in the location sound. I mean, that 3-4 years ago was too much expensive to do that. But now, I mean, that's why, I mean, it is good to show this system, because the way you can work now, you have much more tools for many manufacturers to work in a different way. In this case, the idea is that to help you to put always an antenna close to your shooting place, which is basically solving also the problem of having more interference. Again, you do have more interference because of terrestrial television, of shrinking of the bandwidth, but then there's a lot of workarounds to do that. I mean, that's now you start approaching, as you say, spectrum analyzer, I think. And, but many of these features, I mean, were not used, I mean, that like 5 years ago. But then again, there's a lot of new things coming out. That was basically the systems, like it was 2 years ago. I can show you the system, how it can look like.
Potom to môžeme potom neskôr, nakoľko u nás na Slovensku prenášací antény signál optikou. V podstate dá sa aj do Interškol na také veľké eventy ako Formula. Ak budú, tak máme optiku.
This is the system of this year. So this is an example of the same systems in Formula 1 with the paddock, pit lane, pod. This basically is managing a receiver and this is managing the IM transmitters. So as you see, these areas are very far away. And so the next generation, basically, we are able to put all this stuff within some small pelicanes with a battery backlight. So basically, this is very nice. So it depends, of course, what you're doing. For location sound, probably it's too much. But if you're running like Obi-Wan or covering a football stadium, you can put all your stuff within the Obi-Wan. You have just a small box that is running without power, or it can be just powered by the battery for like 10 hours. You can put within the stadium, and normally, I don't know, normally most of the stadium they're already cabled with fiber optics. At least, I don't know here. I don't know here. And you can keep all your stuff within the Obi-Wan, which is much easier workflow. We've been running, for instance,
U nás to máme v podstate opačne, hej, že nosíme príjimače v podstate ďalej, ale tu je v podstate opačná cesta, že príjimače sú v obývaní, vyťahnete jednu optiku, dáte baterkové napájače, antény si dáte kam treba a není problém.
So just an example about many ways you can run several antenna systems. This is another example of a reality we just installed in Berlin area. We did this in LA, and this is basically close to Berlin. In this case, they want to have all the control room.
It's similar like Big Brother, yeah?
It's a kind of, yeah, the idea is that, I don't know if this is nice or not, they put some people inside here for 1 year, without any...
1 year?
Yeah, without any
it's
help.
Big and Big Brother.
Yeah, it's just, it's kind of extreme, but the idea is that they need to cover all this area, which is like 1 kilometer by 1 kilometer. And of course, the control room and all the services are outside, like 1 kilometer away. So in this case, just put all the antennas, a radio antenna that are managed by RF matrix, so they can turn on the area. This is an example that they want to turn on the area which is live, that they're doing 24/7 broadcasts. And then, but the problem is to cover a big area. There's 1 kilometer by 1 kilometer. So basically, we have two set of antennas with basically all the matrix here. And then all the signal goes back to fiber, to the control room, which is in another place where there's the control room for audio, there's the video server, all this stuff all together in a container, so they can manage this. And of course, we have a redundant part to cover this part here, but it's useful also for redundancy if something happens. So that's an example of an installation that was done like 2 months ago. But this technology, okay, this is a kind of big installation, but are used also for small things. It's like it can be a small theater. We installed, for instance, this to have both stage and the foyer and several parts of the theater. So this is another system. For instance, this is an example of
connecting.
Yeah, connecting. This is basically a product which is not out yet. Okay, it will be announced NAB. So basically, it's the radio matrix you saw before. So basically, this matrix can connect all the RF, and you can select the area. This is, I'm not going to talk about that, but just as curiosity, this is want to be the proposal for the Expo in Italy. We have a worldwide exposition in Italy, and the problem here is to cover a very big area for like 4 teams. Each team has their own fiber, and so in this case we can put the antenna very close to the place they're shooting. So you don't need a lot of
power to run.
Yes. And even if there's a lot of noise, you can work on top of it. This is actually in Italy, so basically there's a lot of noise going on, and we can solve this in that way.
Je to vlastne, že Expo, že to je o tom, sme sa rozprávali, že v podstate v budúcnosti pôjde v podstate o to, aby ste si veľa bordelu nenahnali antenami do systému a tým pádom máte obrovský problém. Takže je to jedno z riešení potom do budúcna aj s optikou, tým pádom dá sa vyriešiť. Nemusíte veľa zisku dávať na antenách, dlhé koaxiály, je to dobre, vieme kovať na dosť veľké útlumy, čo sa týka frekvencií, takže nemusíte to naháňať na začiatku, ale idete pekne v podstate s nízkym šumom až do príjemeču. OK, what's next?
Well, it's let's show something like safe to skip this for another presentation. That is. presentation was done in Denmark 2 months ago. I just with few slides to introduce some concept. It was just beginning of a presentation. The normal question that people ask you, in this case, what's going to be the future? I will be probably shrinking our bandwidth. But the typical question that people used to do to manufacture is that how far your system can run, and how many channels in one TV space, and all these things.
So
do I need diversity? Yeah. Of course, in Italy they say, okay, do I get any that's me, sorry. So, just to show you some concept, that there's no time to get deeper, but just to put you some doubts about the way you work. And then, of course, the only way to practice, just to make an example, how far a system can go. So you can make a real mathematical calculation. And basically, the result is that a microphone with 50 milliwatt power can get 40 kilometers. I think most of you are using wireless microphone, but probably you never experienced 40 kilometers.
Meters, maybe 40 meters.
40 meters, probably. So there is a reason. So basically, because you can make the calculation in different ways. So you have your microphone, then basically you get free space losses. Then you have another thing which is very important. So it's good to understand why your system doesn't work. So as a rule of thumb, your problem is the noise. As I said before, the noise can be LED walls, can be telephony, can be television. There's also another kind of noise that we don't have time to talk. It's the noise that is created by your own system. Technically, this noise is called intermodulation, but yeah, and that is limiting a lot the bandwidth, but we don't talk about that now. Anyway, another problem that you have, which is normally, is attenuation of the body. When the microphone is on the antenna is covered by the body, you can experience an attenuation about 10 to 30 dB. Just to make it.
To vieme.
So we used to think in dB, which is a.
Sorry, it's a joke.
Okay. I don't understand, sorry.
I can translate it.
Okay. No, we used to think in dB because it's the way the electromagnetic wave propagates. But you're working in audio. I mean, the audio, the acoustic wave, the electromagnetic wave, that works the same. I was making some presentation with some DPA guy, and probably don't know Bob Brink, you know. It's a nice guy, but the presentation was making evaluation about the difference of placing microphones in different parts of the body. So normally I got the place which is here, and then the reference is a microphone which is 1 meter far away. So this is basically 25 centimeter and 1 meter. Normally, theoretically, every time you double distance, you lose 60 dB. Okay? So that work for acoustic waves is work for also microphone. Electromagnetic wave. There's the same propagation, of course, different frequency, but the idea is the same. In the case of audio, which is kind of easy to understand, if you have a microphone which is 1 meter far away, which is a certain level, normally the level in acoustic is measured in dB SPL. It just tell you how strong is the signal. If you put a lavalier here, basically, which is 1/4 of the distance, so is twice half of the distance, you lose 50 centimeters, so half of a meter, you lose 60 dB. Another half is 25 centimeters, is 1/4, so you're losing 6 plus 6, 12 dB. If you make a test, you will see that probably a microphone here, you will get roughly 12 to 13 dB less than a reference to a meter. It is the same for the electromagnetic waves. So 6 dB is half the distance, and 20 dB is 1/10 of the distance. So to move from, from 1 meter to 2 meter for a wireless microphone or with a microphone, normal, you lose 6 dB. For 1 meter to 10 meters, you're losing 20 dB. When you put your microphone like this with a body, you're losing 10 to 30 dB. So your coverage is reduced to 10
times?
more.
More than 10 times.
Like 10 to 20 times. Theoretically. Then, of course, attenuation is not the only problem. There is other problem like, we call that fading. Normally there is a lot of reflection within the area, so there's other issue. But attenuation is a very big problem. And that is the reason why normally, and then of course, another problem that you have is the noise. Normally the noise floor of everything is the thermal noise that is on the earth. And if you make basically a calculation like this, you got the level of your microphone to 1 meter distance. Okay, I put some value that does make any sense, basically, but more or less is good. Normally at 1 meter you got like 95 dB microvolt. And then if you basically get the body attenuation in another 30 dB, then you got the fading at 5 dB, then you got 10 times the distance, so another 20 dB, and then basically you got your noise floor, which is the limits, and the squares. So basically, if you don't have all of that,
Moc tam toho neostane, hej.
all of that, so probably you will get 40 kilometers, but in reality, you need to have 30 dB for the body, you have the fading, you have basically the drop for the distance, and you have the thermal noise and the square. So basically, that does tell you that the coverage of the microphone is not mainly due to the power, but is really dominated by the position of the antennas and the fact that the antenna may be covered by some obstacles. This is true for the body, as an example, but for instance, if you work in the theater, one of the big problems of the theater is that they have a movable scene, which sometimes they are made by metal. That creates a lot of problems. Theater, putting this fixed antenna on theater with movable elements is a really big problem. So, means that antenna, antenna is a very big issue. That's why that's when I approach this problem for big events. The main attention is how to make the best coverage of the antenna, because if I increase the power of this microphone, you can make us, I get 3 dB. If I get a better antenna position, I can get 30, 20 dB advantage. So the position of the antenna is very critical, and it is actually more critical if you're doing big shows or if you're working in a situation where this noise is high. So you need more margin, you need this to be smaller.
To je to v podstate v tých letkových, že prečo z tých 40 km zostane pár metrov a tak či tak začíname a končíme pri anténach, takže v podstate tá prezentácia o tých anténach, čo bude potom po coffee breaku, bude asi aktuálna, že to ľudské telo to vieme, že vlastne nám zožerie v podstate veľkú väčšinu vzdialenosti, letkové stenia samozrejme skvel, čo sa týka systému, musíte mať potom vyššie, takže moc tam toho nejde.
Okay, quickly.
Yes.
I was just wanting to introduce. Another problem that you have, you don't see actually, but when you move with a microphone within a room, because of reflection, you create a lot of
reflections.
No, this is basically a lot of situation where the two signal goes in phasor position. I don't know if you ever experienced the first telephone GSM, like 1993, something like this. It was the first GSM without any diversity or whatever. I don't know if you remember that you have to find a position to have a nice talking with. This system are kind of much better than the other. But anyway, reflection is a big problem. Normally you work in the professional field with a diversity system. So basically you put two antennas, so you have a reflection on one antenna, not on the other one. So this probably is something you don't see because you're using diversity systems, but it is a problem when you're covering big areas. So there's also another. Was also another kind of diversity. I was just to show you something. Diversity means having different receiver. We can make diversity also in frequency.
A potom ešte existuje frekvencia na diverzita.
So basically, this is an example. This is coming. We've been using this since 15 years. When you do a very big events, like we do like a marriage or Queen of Sweden or something that's you have very big VIP worldwide live, you cannot afford the body pack to fail. Normally people they put two body pack, two completely different audio channel, because to fail that the guest feed is not an option. In this case, basically normally they got a receiver with two feed on the mixer, and if something goes wrong, basically they use the other audio. That is pretty normal. Now we have systems that have very powerful DSP on board. So basically we use basically this kind of concept to continually switching between the two frequencies. So we have basically two antennas, so we have space diversity, and we have two receivers that is only making diversity between the two. So in that way, basically if you are running with an antennas, and you put your body pack at the two sides, if I'm doing like this body pack will be on line of sight with the antenna, so it will be very strong signal. This one doesn't work, probably we did an attenuation of 30 dB. But the DSP on the systems can recognize this situation and switch on this body pack. So basically we can also, in this case, with two body pack, we can also recover a little bit that situation, let's say on the back, the body attenuation, because with two body pack, it's very unlikely that the two body pack are covered by the body. Of course, you don't get all the 30 dB, but instead of 30 dB, 20 dB loss, you get like 6. Means that you are recovering like 10 dB. 10 dB is a lot. It's like 3-4 times the power. It's like instead of having a system 50 meter, you have a system half a watt.
Yeah, half a watt.
So that's basically the idea. But I just introduced this because I just want to show you something. This is basically, we've been making some tests for a big sports event. I don't know if you see basically Tour de France or big competition. This is a very big problem because when you follow a competition like this, the bikers are on the mountain. And you know, the mountain, when you are in the curve of the mountain, there may be some rocks covering the head of the competition, the back. So it's very difficult. So we make a test, as I can show you. We're making actually a test.
Toto môžeme potom tiež cez prestávku, že ohľadom frekvenčnej diverzity. Neviem, či v našich finančných podmienkach by sa to dalo, ale je tu možnosť v podstate, hej, potom sa môžeme baviť. V podstate tá mašina vie nie len to, že máte diverzitu v podstate v anténach, ale máte diverzitu to, že keď máte dva opaskové vysielače, tak ten systém behom mikrosekundy vie prepínať medzi dvoma nezávislými frekvenciami na tej istej mašine. Ani to nepočujete. Toto je príklad.
Okay, we did it in Wisycom because we are very close to. So we are in Bassano del Grappa. Basically, we are in a part of Italy where the flat of Italy, you've been there, it's finished, and then there is a 2,000 meter. So basically, we decide to make a test, being on the company, and to put two antennas on a car, so to speak, simulating a bike. A motorbike that can be on the Tour de France or Tour of Italy, whatever, a big bike competition, and making a diversity system. So basically, we have a transmitter set like this, sending two frequencies, and a receiver like this with receiving the two frequencies of the two diversity receivers, linked in the frequency diversity mode. But diversity differently. What you do normally? Normally, you do the same audio on this and this. The way the receiver will switch on the audio, but must be the same audio. But in order to understand how the diversity will work, we on purpose put two different tones on the two audios. So one frequency was with 1 kHz, the other frequency was with 400 kHz. So you can hear if the diversity were working or not. And then we basically move on top of the mountain, which is a 2,000 meter mountain, about 30 kilometers far away. So it was kind of
40 kilometers?
It's like from the place where we are, on top is a 29 kilometers.
29?
Yeah, I think line of sight would be like 10 kilometers, 8 kilometers at the top. And
the receiver antennas you are in the head office?
Yeah.
Okay.
So.
And which you are using 2 watts? MTK or what?
Yes, I think 500 milliwatts.
100 milliwatts?
500.
500?
Yes.
Really?
Yes. But it's a nano side, like. But anyway, the idea is that to understand how that could be effective. So basically, this is the two channel here. You see the two frequencies, and basically we run with the car. This is the GPS of the car and the video also. We run. You see, that's probably. This is 1 kilohertz, I think, right?
I think yes.
Yeah, 1 kilohertz. And then, and then we run on top of the mountain. I'll show you the other video. Here. Then we have. So basically, if I don't have the diversity of frequency, all this change of tone would be a drop. Here, the other is a 400 kilohertz. So normally, we've been using the same audio, so we not hear this, but we do it on purpose to hear that. So this is, you see that we are on like 2,000 meters of the mountain. I mean, just to show you that there are many options that you can have on an existing system. You're not the only manufacturer to do that. I just want to talk generally speaking. There's many things that system now, because of DSP, because of all this technology put in the system, can do. And that can help you a lot. I mean, this frequency, for instance, using this frequency diversity can help you in a situation where you have
When you need
noise. For instance, I mean, recovering like 15 dB of noise. I'll show you before what was that? So recovering here, 15 dB of noise is like 15 dB here is like that. You can work with 15 dB more noise, or you can work on top of terrestrial television. In many cases, you are able to do that, recovering with a better antenna position, and again putting more antennas. I mean, those technologies are available, but again, we think in the future. You should start working like this. I mean, it's not the case that you are proposing a spectrum analyzer to people, and in many cases we put a lot of effort, electronics also in our products in order to help people. For instance, I was making some seminar in the States, and one of the problems that there was in Los Angeles was basically named to location some people. And those people that make the shooting movies and they have like cart, and they like to show you your card. They put a lot of things on the card,
yeah.
You know. And one of the problems they do have is they ask you is that how to place antennas. How? Because it is not an easy. I mean, here you see some different antenna, whatever. But the problem is when you're in the real sites. It never happened that you're shooting like a free space, like probably doing a documentary, that's free space. Normally you got building, you got a lot of stuff. So basically, the way the antenna is working is predictable, but the optimal position is not predictable at all. For instance, I was running with some people the design of, what was the last Olympic was in Sochi, I think.
Yeah.
And one of the problems there was that there was a very big system, like it was 1 kilometer to cover, and there was also doing something pretty bad. I don't know if you saw the open ceremony. There was like flying elements made by metal, and there was like 100 people dancing on the playground of the stadium. So it was kind of difficult also to understand the coverage. And normally what you do, I mean, when you just make a design, thinking about how could be the coverage, and then you send some people with a spectrum analyzer, checking every point. So, in Wisycom, but also other manufacturers, we are making a lot of tools for you to check this. For instance, on the latest receiver, we put basically tools where you you can see the minimum, the maximum of RF over an area. So basically you can move the antennas. I understand that, or you can use a tool like this to do this job. So it's really important to understand that this kind of antenna placement is theoretical. So you need to understand how antenna is working, but then I would say that 20-30% of optimization is practical. So you need to be able to have this tool. The point is that there's no reason why I would say location sound engineer has to use a spectrum analyzer for many reasons, because using a spectrum analyzer can be very problematic, because if you don't know how to use it, you may see intermodulation within the spectrum. I saw very bad things. So it is much better to use a tool which is simpler, but can allow you to have an idea about how to fix this. So,
dobre, to je to, čo sa týka anten v podstate. Dúfam, že také základy, že to nemusíme. Frekvenčnú diverzitu máme. What's next?
Well,
Coffee?
Coffee maybe, yeah.
Dobre, ešte kým si dáme kávu, tak...
No, sorry, no? Things, no. The idea with this talking is that it's more just giving some idea about the system is working, because there's no time to get deep into all these technologies. And then, of course, it's for you to check, of course, Boris and the other people, whatever. There's many manufacturers that give you this kind of information. I mean, it's more interesting for me to explain to you what we think is happening with the frequency and which are the solutions that are available now, understanding that there's different way of working. And of course, if you have some question after coffee, it would be nice to maybe to talk about specific. I have others, let me say, installation to show if you like a different scenario, but I mean the aim of this presentation was most to give you doubts. But of course, Boris and can explain that. So, can we have a coffee now? I think.
Ešte, ak môžem, tak ja vám to, čo som slúbil na začiatku, ešte také tie naše skúsenosti. Can you switch the main wireless, the second. No. It's the first part. This is the first part. No. This is yours. Or maybe it's not open. It's neutral. OK, takže zatiaľ ďakujem Massimovi. Thank you so much. And cez prestávku samozrejme, že je vám k dispozícii.